In our final expected value video, we're going to talk about games of chance, lotteries, raffles, and Las Vegas type games, all these games of chance that people play. Our objective, use expected value to determine the long run average of how much you will win or lose in a game of chance. So every time you play, what is the average going to be of winning or losing on a per game basis over the long run? Okay, what do we know coming in? Well, this should look familiar. We know what probability is, the chance that something will happen. Probability of an event happening is always between 0 and 1. To find the probability of an event happening, the denominator is the total number of outcomes, and the numerator is the number of ways the event can happen. We know that the probability of an event happening plus the probability of the event not happening covers everything. And so that equals 1, or 100%. And finally, we know that expected value is the long run average. And we find it by taking the sum of the products of each outcome times its probability. Let's take a look at an example involving a six-sided die. Okay, I think I'm good. A game is played using one six-sided die. If the die is rolled and it shows a 1, 2, or a 3, the player wins nothing. Okay? If the die shows a 4 or a 5, the player wins $3. If the die shows a 6, ding, 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 the player wins $5. There's a charge of $1 to play the game. So what is the player's expected value? Okay, so in this situation, you're the player. Okay, so you play. If your outcomes, well, we have 3 outcomes. You could roll a 1, a 2, or a 3. That's one. These 3 outcomes have the same gain or loss and the same probability. Okay. Let's see. So if you roll a 1, 2, or a 3, well, you spent $1 to play and you won nothing. So you spent your winnings were nothing. You spent $1 to play, and therefore you have a loss. You have a loss of $1. Okay, so rolling a 1, 2, or 3 results in the loss of $1. Now, what is the probability that you roll a 1, 2, or a 3? Well, there are 6 outcomes. Here's one of them, here's a second of them, here's a third of them. So you have a 3 in 6 probability of rolling a 1, or 2, or a 3. So half of your rolls are going to be a 1, 2, or 3. Half of your rolls are going to result in a loss of the $1. What happens if you roll a 4 or a 5? Well, if you roll a 4 or 5, you win $3. But of course, you played $1 to play. You paid $1 to play. So your gain, I'll use a plus sign for gain, you gain $2. Okay, you won 3, but you played $1. You paid $1 to play. So you didn't gain $3, you only gained 2 because it cost you $1 to play. And what's the probability of rolling a 4 or a 5? Well, there are 6 outcomes, and 2 of those are a 4 or a 5. Your final outcome is you roll a 6. If you roll a 6, you win $5, but that's not your gain. Again, you paid $1 to play, and so your gain is a positive $4. Okay, that's the big winner, obviously. You won 5, but you were charged $1 to play, so your gain is $4. And the probability of rolling a 6 is 1 out of 6. Let's remind ourselves we need to account for all possibilities. So we add up these numbers. 3 6 plus 2 6 plus 1 6. And we want to make sure that sums to 1 to make sure we have 100% of all possibilities accounted for. Every possibility being accounted for. Okay, so the expected value, E is equal to the sum of the products of each gain or loss times its probability. Okay, so let's take a look. Okay, so each gain or loss times its probability. So these outcomes they're not going to be involved in the math. I could have written them in words if you wanted to. We're looking at the gain or loss again times the probability. So in the first outcome of rolling a 1, 2, or 3, you have a loss. So I use a negative 1 to indicate that loss of $1, and the probability of losing $1 is 3 out of 6. Let's add that to the next product. If you roll a 4 or 5, you have a gain of $2. So a positive $2, that's a $2 gain. And the probability of getting a gain of $2 is 2 out of 6. And finally, the third outcome, you have a gain of $4, so a positive 4. And the probability of getting a $4 gain is 1 out of 6. So the sum of the products, here are my 3 products, product, 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 and then I add them all up. Do the math. This is a calculation. Into a calculator it goes. And the long run average of playing this game turns out to be 83 cents, positive. So the more you play this game, you're going to wind up seeing that you're going to win 83 cents every time you play, on average. Okay, so in the long run, again, it may not happen on the first game or second game, but the average as you continue to play, you'll wind up winning 83 cents on average for each game played. In the long run, okay, the player, you, can expect to win an average of, and I used the dollar notation, that's 83 cents for each game played. Now, is this a good game for you? Yeah. You're winning 83 cents every time you play on average. Is this a good game for the person who is running the game? Maybe Las Vegas, for example. Well, no. Because every time you play, they're losing 83 cents on average. So this is a game you will not see in Las Vegas, because in Las Vegas, this is a game in which they lose money on average each game played, and that's not how Las Vegas makes money. In Las Vegas, every one of the games that they play, they make money, and you lose money on average for every time played. So this is a good game with a positive outcome for you, but it's not a good game for the person who is running the game. In my example, that would be Las Vegas. Let's take a look at Las Vegas in the game of roulette. Speaking of Las Vegas. Okay, so let's talk about playing roulette, which works out very well for expected value. Okay, my second example. One way to bet in roulette is to place $1 on a single number. Okay, and there are a total of 38 numbers. There's a roulette wheel. There are 38 slots, if you will, and you're going to each have a number from 1 to 36, and then there's a 0 and a double 0, so there are 38 numbers. And you're going to place $1 on a single number. That's one way you can bet the roulette wheel. If the ball lands on that number, you win $35. And you get to keep the dollar you paid, okay? The dollar you paid to play, that's pretty cool, okay? If the ball lands on any of the other 37 numbers, you lose $1. The person who's running the game just simply takes your dollar chip away. Okay, what is your expected value for placing a $1 bet on the number 20? Let's look at our outcome in words. Okay, so what happens? Well, first off, you could win. And what winning means is ball lands on the number 20. That's a win. Okay, if you win, well, you get $35, and you also get to keep the dollar. So your chip goes on the 20 space, and you keep the chip, and they give you the $35. Now, that doesn't mean your gain is 36. Your gain is 35. The dollar was yours to begin with. So your gain here is a $35 gain. Again, the dollar was yours to begin with, and so you're only gaining $35, okay? And the probability of doing that, well, there are 38 spaces or slots on the roulette wheel, and one of those is the number 20. So the chances of the ball landing on 20, or the chances of you winning, is a 1 in 38 chance. Okay, what's the other outcome? Well, you lose. In other words, the ball does not land on 20. Okay, it lands on any other number but 20. Those are the only two outcomes in this game. You're either going to win it or you're going to lose. Okay, if you lose, well, the dollar just goes away. The person running the game takes your dollar chip and says, okay, place your bets for the next game. So you are out, you lose $1. We'll indicate that with a minus sign. And the probability of losing, well, if 1 in 38 is the probability of winning, and winning and losing are all the choices, we subtract to get the probability of losing 37 out of 38. Because as we know, this one plus this one equals all possibilities. 1/38 chance of winning plus 37/38 chance of losing is 38/38, and that's everything. And we need to account for everything here. Okay, 100%. So what's the expected value? Well, let's think about this just for a second. This is Las Vegas. As I mentioned earlier, they're not in this to give money away, they're in this to make money. So we're expecting that your expected value is going to be negative. Okay, you're not going to make money in the long term on this. Again, they're playing a game. It's entertainment is what they see it as, and so you're paying to play, but you will be losing money in the long run. What do we know? So expected value again, the sum of the products of each gain or loss times its probability. Okay, so the first one, if you win, there's a gain of $35. Indicate that with a plus 35. And the chances that you win are 1 in 38. Plus the sum of the products. Well, the next product, the next possibility, the next outcome is a loss. It's the only other outcome. If you lose, there is a loss of $1. I'll indicate that with a -1. And the probability of losing $1 is 37 out of 38. Okay, and that accounts for everything. You either win or you lose. This is a calculation. Take out your calculator, do the math, and this comes out to be a very small loss of 5 cents on average every time you play. Again, let's talk about what that means. Okay, you may win the very first time. That's true. But if you play this game over and over and over again, the average for each time you play, if you add them all up and divide by the number of plays, you're going to average out to lose 5 cents every time you play. So Vegas is counting on this from their perspective. Okay, from their perspective, if you win, they lose $35. If you lose, they gain $1. That's Vegas's perspective. Okay, that a win for you is a loss for them. Okay, so from Vegas's perspective, they're winning 5 cents on average each time this game is played. And when millions of people play, the 5 cents will really add up. Okay, so Vegas is fine with it only being 5 cents because they know millions of people are playing. And at 5 cents every time that it spins, they'll take that because they just win 5 cents over and over and over again. And again, back to you, you can expect to lose 5 cents every time you play on average. Is it worth it? That's up to you. Okay, so again, let's write this in words. In the long run, okay, you play over and over again. Okay, if you play over and over, you just sit there at the roulette wheel and you keep betting on a single number and just playing and letting it spin. Okay, you can expected value, you can expect to lose an average of 5 cents. That's the dollar form of 5 cents, $0.05. Here's the cents form of 5 cents for each game you play. Okay? And again, remind you that there's a different perspective here. This is your perspective, but from Vegas's perspective, they're gaining 5 cents in the long run for every game that's played. And that's how they make money. So there you have it, expected value in both business or kind of real life applied applications and in games of chance.